We've talked about scalar multiplication, but we haven't talked about matrix multiplication, by which we mean multiplying one matrix by another matrix. And one of the things we're going to need to keep in mind is the size of the matrices as we do this process. So in your textbook, the first topic is the size of a matrix product, but I'm going to do a very simple matrix multiplication to start with to show you why that size is important. Matrix multiplication involves multiplying each row, each entry in each row of the first matrix by the entries in each row of the second matrix. So for our first pass at this process, we're going to have, let's see, I think I'll use a colored pencil here. We're going to have 2 times 0, which is 2. Then we'll have 1 times -3, which is -3. And then we'll have 0 times 0, which is 0. And we're going to add those up. I get -1. All right. And then I'm going to do the same thing, but this time I'm going to multiply the first row times the second column. And I'll do it in the same way. I get 2 times, let's do it this way, 2 times 1, which is 2. Then 1 times 1, which is 1. Then 0 times 3, which is 0. And I'll add those up, and I get 3. In the next step, I repeat the process again, but this time multiplying the second row by first the first column, and then by the second column. So the first row by the first column, -3 times 0 is 0. 0 times -3 is 0. And 3 times 0 is 0. Of course, when I add those up, I get 0. And for my last pass, I'm going to have the second row times, in the first matrix, times the second row in the second matrix. So I will have -3 times 1, which is -3, 0 times 1, which is 0, and 3 times 3, which is 9. And I'll go over this process again. This isn't actually the right place for it in the textbook, but I wanted you to see why the first topic in the textbook deals with the size of a matrix. So the reason the size of a matrix, the size of the product is important, the reason the size of the matrices involved in the product is important, is that I only have 2 rows here. So if I had 3 columns, I wouldn't be able to do this multiplication. This is a 2 by 3 matrix, and this is a 3 by 2 matrix. And I was able to multiply the entries in the rows of the first column with the entries in the the entries in the rows of the first matrix with the entries in the columns of the second matrix, because the number of entries in the rows of the first matrix and the number of entries in the columns of the second matrix match, right? And when I say this is a 2 by 3 matrix, I mean it has 2 rows with 3 columns. And when I say this one's a 3 by 2, I mean it has 3 rows of 2 columns. So since the rows of the first and the columns of the second, the number of entries have to match, you'll notice that these 2 numbers match. They are the same number. If those 2 numbers are not the same number, you will not be able to do matrix multiplication. So even without knowing what the matrices are, if I say A is a 2 by 4 matrix and B is a 3 by 7 matrix, find the product AB, I'll have to say that product does not exist because this 4 and this 3 are not the same number. I will not be able to perform this multiplication. We haven't talked about where these numbers should go. So I'm going to do that now as well. Remember that we got the first sum here, the first number, by multiplying the first row in the first matrix by the first column in the second matrix. The second number, the 3, we got by multiplying the first row by the second column. Then we multiplied the second row by the first column and the second row by the second column. And if you make each of those the subscript, oops, let me fix that. Make this A1, make the 1, 1, the 2, 1, etc. Make that the subscript on an A, where A is the number in a matrix position. Then you'll see that what you have is A1, 1, first column, first row, A first column, second row, A second column, first row, and A second column, second row, and you've got this, you've got a 2 by 2 matrix as a result. So in this case, my result is going to be, my matrix is going to be -1, because that's the result of multiplying the first row and the first column. 3 is the result of multiplying the first row with the second column. 0 is the result of multiplying the second row with the first column. And 0 is the result of multiplying the second row with the second column. So this matrix is the result of this matrix operation. Sorry, multiplication, matrix multiplication. It's also worth noticing that the resulting matrix is a 2 by 2 matrix, and that can be predicted by the fact that we have 2 rows to multiply by 2 columns. So the entries in those columns, we could have a 2 by 7 and a 7 by 2, or a 2 by 23 and a 23 by 2 matrix. Our resulting matrix will still be a 2 by 2 matrix. Okay, let's do one more example. And I'll do the next one fairly quickly because I don't really want to focus on the process of multiplication in this video. I really want to focus on this idea that the numbers in the middle have to match, and the numbers on the outside tell us what the size of the product is. So the size of the matrix is. So I'm going to, first of all, try to do an example where you can't do the multiplication, just to show you one of those and kind of convince you that the these inner values have to be equal. And then I'll do another example with slightly different sizes of matrices. All right, so this is my example of a matrix product that does not exist. I can't multiply these two matrices together. And the reason is this. The first matrix is a 2 by 2. The second matrix is a 3 by 2. And I can tell just by looking at them that they're not going to multiply because the 2 and the 3 in the middle don't match. But let's just take a very high-level view of why this is happening. The product of two matrices is the entries in the first row of the first matrix times the entries in the first column of the second matrix, and then I'll add those two numbers together, right? I'll add those products together. But what that product is going to entail is multiplying each entry, 1 times 1, 0 times 0, and there's nothing here. There's nothing in a third column in the first matrix to multiply by this 1. There's nothing to multiply it by. So I don't even need to go any further. I'm not able to proceed with this multiplication problem. So that's why it's important that these two numbers match. In this case, they don't, so I can't do this problem. Okay, in this example, I have a 3 by 3 matrix and a 3 by 2 matrix. So I can do matrix multiplication, which is important to know, and my resulting matrix will be 3 by 2. So I'm going to start with the first row, first column. I get 1 times 1, 0 times 2, 2 times 0. Add those together. I'm doing this from the first row, first column, so that's my A11 entry. and that's 1. That's my first row, first column. Then I'll do my first row, second column, and I get 1 times 0, 0 times 1, 2 times 3, 0 plus 0 plus 3 plus 6, and that's my first row, second column, so that's my A1, 2 entry, and that is 1. Out of column, so I'll go to the next row in the first matrix, and I have the second row, first column, which is going to be 2 times 1, which is 2, 1 times 2, which is 2, that's 4, and 0 times 0, which is 0. Add those together and I get 4. These are from my second row, first column. So second row, first column of the new matrix is 4. Then I have second row, second column. So let's see, that is 2 times 0, which is 0, 1 times 1, which is 1, 0 times 3, which is 0, and I have in my second row, first column, I have a 1. And let's see where, that's the second row, second column, so I'm done with the second matrix. So I'm going to go back again now and do the third row with the first column. That's going to give me 0 times 1, which is 0, 1 times 2, which is 2, 1 times 0, which is 0. 0 plus 2 plus 0 is 2. Third row, second column goes in the third row, second column of the resulting matrix. And last but not least, I have the third row with the second column. So I'm going to have 0 times 0 plus 1 times 1 plus 1 times 3. That's 1 times 3, which is 4. Third row of the first column with the second row of the, third row of the first matrix with the second column of the second matrix. Third row, second column goes in the third row, second column of the resulting matrix. Now I've lost track of what I had here. 0 plus 1 plus 3, so 4. This is the result. If this is matrix A and this is matrix B, then we would say this is AB equals. This is the product of matrix A and matrix B. The primary focus here, though, has been to remind you or to show you that that it's important that these two numbers match. The inside dimensions of the matrices match. The number of columns in the first matrix and the number of rows in the second matrix must be the same. When you're doing this multiplication, the result will be a matrix the size of the outside dimensions of the multiplication. So that is why the size of a matrix product is the first topic in this section. I think it's a little bit out of place because until you know what you're actually doing and what matrix multiplication looks like, you can't really see why that's important, which is why I've gone to so much trouble to sort of do some examples here. So it's a fairly straightforward idea that without a foundation doesn't really mean anything. So apologies for the 13-minute video for such a simple idea, but I wanted you to see why it's important.